All right, today we are taking on operations with radicals. We are going to be adding and subtracting. So here my instructions are to perform the operation and then simplify. I'm going to do all of the odd problems in this left column, and then I'm going to pause and have you guys work through all of the evens on the right, and then you can unpause and watch me go over them as well. Okay, so the first thing to note is that we really cannot add or subtract radicals, so square roots, unless they have a common radicand. So the number that's underneath the radical right here, that radicand is 7. It has to match the 7 right here. So it's similar to when we're adding two linear terms, let's say. Let's say that I have a 2x and a 3x. I can combine those to make 5x. 2x plus 3x would equal 5x. They are like terms. I can combine them. If I had 5x plus 2x squared, I could not combine them because those would not be like terms. So here I need to get my radicands to match in order to combine them. So the square root of 7 plus the square root of 7, so it's 1 square root 7 plus 1 square root 7. Those radicands match, so I can combine and make that equal to 2 square root 7. 2 times the square root of 7. Just like if I had x plus x, that would be 2x. So similar idea transfers to our radicals. So in my next one in 3, 2 square root 6 plus 3 square root 6, those radicands match. They're both 6. So I can add the 2 and the 3. I have 5 square root 6. Okay, looking at my next one, let me just slide up a little bit. So if I look at problem 5, here I have 4 square root 10 minus 9 square root 10. So again, the radicands, they match. They're both the square root of 10. So I can say 4 minus 9 gets me a negative 5. So negative 5 square root 10. Okay, and my next one in 7, here I have 11 square root 5 plus 11 square root 6. So my issue here is I have the square root of 5 and I have the square root of 6. So the radicand 5, the radicand 6, they're not the same. So I cannot push forward. I can't simplify at all. My final answer would just be 11 square root 5 plus 11 square root 6. So here I could not push forward. There's nothing I could do to consolidate because they had different radicands. So here, just a little reminder that we can only combine if the radicand, so if those radicands match. So here there was nothing that we could do to simplify. The square root of 5 is just not the square root of 6. All right, we have 2 more. So in problem 9, I have 3 square root 8 minus the square root of 50. So at first glance, those radicands don't match. But when I look at them closer, I can see that, oh, well, they can each simplify. So I have 3 square root 8. So if I simplify the square root of 8, I'm just going to underline that 3 so I don't forget that it's there. So I know that 8 is 4 times 2. And that 4 will give me a pair of 2's. So this term is really 3 times 2 square root 2. 3 times 2 square root 2. 6 square root 2. So I was able to simplify this one down, and now it reads as 6 times the square root of 2. And the square root of 50, I know that simplifies also. That's really 25 times 2. That 25 will give me a pair of 5's. So the square root of 50 is really the same thing as 5 square root 2. So now, once I've simplified each individual term, I have 6 square root 2 minus 5 square root 2. So now their radicands do match. They're both in terms of the square root of 2. So I can take that 6 and subtract 5 and get 1. So this would be 1 square root 2, which we just write as the square root of 2. So just like when we write x, we know that that reads as 1x, but we don't write the 1, but we know that it's there. So here I have square root of 2 is the same thing as 1 square root 2. All right, for problem 11, here again, first glance, I don't see any like terms. So I need to make sure that I simplify each individual piece to see if I can find common radicands. So if I look at that square root of 125, I know that that's 25 times 5. And that 25 will give me a pair of 5s. So really, this becomes simplified 5 square root 5. Okay, that next term, that 3 times the square root of 20. I'm going to underline the 3 so I don't forget about it. And then the 20, I know that that's 4 times 5. And that 4 gives me a pair of 2's. So I really have 3 times 2 root 5. So right now I have 5 root 5 plus 6 root 5. Okay, and then I have to take away the square root of 24. So if I break that down, I know that that's 4 times 6. And then here's a pair of 2's. 6, I'm not going to have a pair in 6. It's just 2 times 3. So I can stop it right there and say that this becomes minus 2 root 6. So right now I have 5 square root 5 plus 6 square root 5 minus 2 square root 6. So the only terms that I can combine are the ones that have a common radicand. So I can only combine these two right here. So when I add the 5 and the 6, I get 11. So 11 square root 5, and then minus 2 square root 6. And that would be my final answer. That's as simplified as I'm going to get. All right, I would love it if you would hit pause for a moment and then do all the even ones in that right-hand column on your own, and then unpause it and look at the answer key or watch me go over these problems. All right, I'm going over them now. So here I have the square root of 5 plus the square root of 5. So again, they have the same radicand. I see a 5 here, I see a 5 here, so I can go ahead and combine and make 2 square root 5. Okay, here I have 9 square root 3 plus 1 square root 3. So the 9 plus the 1 will make 10 square root 3. Okay, next, we push up a little bit. So here I have 3 square root 2 minus 8 square root 2. So again, they're both square root 2. So I can take the 3 minus the 8 and get a negative 5 square root 2. Okay, here looking at 8, I have 12 square root 7 plus 12 square root 3. So the 7 and the 3, those radicands, they don't match. There's nothing I can do to simplify individual terms. They're already simplified. So this is really my final answer. There's nothing else I can do. It's already simplified. So I have 12 square root 7 plus 12 square root 3. Again, I can only combine if I have radicands that match. It is just like when I have 4x plus 6x. If I'm adding those two, I can make 10x. But if I have 4x plus 6x squared, I cannot combine a linear with a quadratic term. Okay, same thing translates to the radicals. We can only combine if they are like terms, and like terms means that they have a common radicand. The number underneath the radical is the radicand. All right, problem 10. So here, at first glance, they don't appear to be like terms, right? Because they have different radicands, but I can simplify each individual term. So I know that there's a 4 on the outside, So I'm underlining it so I don't forget. And 27 is 9 times 3. And then here I have a pair of 3's. So I have 4 times 3 root 3, which will get me 12 root 3. Okay, and then I have 5 times the square root of 48. So 48 is 16 times 3. And 16 will give me a pair of 4's. So this reads as 5 times 4 root 3. So 5 times 4 root 3. So I get 20 root 3. So now that I've simplified each individual term, I can see that they're both in terms of the square root of 3 now. So if I add the 12 to the 20, I get 32, and then square root 3. Okay, and then my last one, problem 12 again. First glance, they don't appear to be like terms because they have different radicands, but I can see that I can simplify each individual term. So again, I'm going to underline that too. I don't want to forget about it. And then 54 is 9 times 6. So 9 gets me a pair of 3's. I'm not going to have a pair in 6, right? That's a 2 times a 3. So no pair in that 6. I'll just stop there at the 6. So I have 2 times 3 and then root 6. 2 times 3 and then square root 6 like that, which will then become 6, square root 6, just like so. Okay, next I have the square root of 28. So I know that that's 4 times 7, and that 4 gives me a pair of 2's. So 2 square root 7 next. Okay, and then lastly, I have 5 times the square root of 96. So 96 is 16 times 6. That 16 will give me a pair of 4's. And again, I know that there's no pair in 6, so I'm going to stop there, dead end right there at the 6. So I have 5 times 4 square root 6. 5 times 4 square root 6, which is 20 square root 6. So now when I look at this, I'm looking for anything that I can combine, and I see that right here, the 6 root 6 and that 20 root 6, those are like terms. They both have the same radicand, the number underneath the radical, so I can combine these two. 6 plus 20 is 26, root 6, and then minus 2, root 7. And I also just want to remind you that the order that you write them doesn't matter. So if you flipped these around, that would actually be okay. That's perfectly fine. Your answer would be equally correct. All right, that's all I have for today. Enjoy the rest of your day.